Now it's time to understand the principle of conservation of mechanical energy. Very first case, maximum height. So here the red line represents the maximum height. Let's say this is the maximum height h, and this is, let's say, at C point. This is C point, this is B point, and this is A point. So this is C point, this is B point, and this is A point. The maximum height is h. And C to B, this height is x. So total height is h. So A to B is h minus x. So this is the very basic idea of this concept. Now our main objective is to prove that at A point, at B point, at C point, the total energy are equal. In that case, we can say that the conservation of mechanical energy at every single point of ABC. So very first point is C. So at this point, the object is this one. So when the object is at C point, so at C point, their h actually 0. So the potential energy is obviously mgh. So h is 0, so it will be 0 joule. So if we throw this object towards upward, so the maximum velocity we have to apply here. So here the maximum velocity we apply here. As a result, the kinetic energy will be half mv square. So total energy at point C is equals to, this is ek, so ep plus ek is equals to half mv square. So this is total energy for at C point. So at C point, let's say the velocity is vc, so obviously this will be vc. And when this object goes towards the maximum point, at this point the velocity, the final velocity, of course it will be 0, and then it will be again fall down, right? So the equation for the final velocity v naught, I mean this v square, is equals to vc square, as this is goes upward against the acceleration due to gravity. That's why this is minus 2g, and the maximum height is h. So we could write down v naught is 0, so vc square minus 2g h. So we could write down vc square is equals to 2g h. So if we plug in the value of vc square here, so at C point, the total energy will be half m, and v square 2gh. So these two cancel out, so we could write down mgh. Okay, so now it's time to determine the total energy at B point. So at B point, the potential energy EP, let's say B, is equals to mg. How much height it will be? It is x, so we have to write down here x. So the potential energy is very straightforward. but the kinetic energy will be half m VB square. So what is VB? So here is VC and here is VB, right? And the distance is x. Indeed, what you can write, we can write VB square equals to VC square minus 2gx. And what is the value of VC? VC is 2gh. So here let's write down this equation here for better understanding. So we could write down VB square is equals to VC square. So VC square is 2gh minus 2gx. So 2gh minus x. Now it's time to plug in this value of VB square here. So we could write down half m. VB square means 2gh minus x. And here it is very straightforward. Let's cancel out 2. So we could write down mgh minus mgx. So at B point, the total energy, let's say EB is equals to EK B plus EPB. Now it's time to plug in the value. So EKB means mgh minus mgx plus the value of EPB is mgx. This value we have to plug in here. So mgx cancel out. So the total energy at a B point is mgh, which is equal to the total energy at point C as well. So remember, the value of total energy at C point same as at B point as well. Now it's time to calculate at A point the potential energy EPA is equals to mgh. So of course here the total energy is mgh because the maximum height, remember the image represent from C point to A point, so maximum height is traveled by this object. So and the mass is m and the maximum height is h, and the kinetic energy EKA is equals to half m v square. Remember the value of the velocity at A point v is 0, so there is no velocity exist. In that case it will be 0. So the total energy at A point E equals to EKA plus EPB, so mgh. So at every point, at A point, at B point and C point, every point the total energy is mgh. So conservation of mechanical energy is conserved. So we proved that at every point, at A, B, and C point, the total potential or total energy is mgh, so which is equal. In the second case, let's consider this is a simple pendulum. So this is the pendulum, let's say this is the bob, as you can see at A point, and obviously this circular point or circular object is a pendulum. Anyways, this pendulum is moving through A to B, B to C, again C to B, and then again A. What you have to do, we have to prove that at A, at B, at C, at every single point where the total energy, it means the mechanical energy, is equal. In that case, we can say the law of conservation is maintained. So our very first task is to calculate the total energy at point C. At point C. At point C, so here let's say there is height is PA from P to A, and up to B the height is A to M, and from B to C, the height is nm, right? Hope you understand this thing. So the very first A to B height is am, and then B to C height is mn or nm, and the total height, which is the length of the cord or length of the string, which is PC, PB, and PA, these are equal, right? Now at C point, the pendulum need to be released from C. So at C point there is maximum potential energy. So potential energy at C point is mg, and height is, as I said, an, so it need to be right A and n, right? And at this point, at C point, it is actually stopped at this point and then released, right? Indeed, at C point there is no velocity, so Vc is equals to 0. Indeed, kinetic energy at C point is 0. So the total energy at C point is equals to E PC plus EKC. So the value is mg an. So the total height will be an. Now it's time to evaluate the value at B point. At B point, so at C point there is velocity Vc is equals to 0. At Vb equals to, we can write down actually, V square equals to Vc square plus 2g, and height is how much? This height is mn, so we could write down here m and n. Now it's time to write down the potential energy at B point. So EPB is equals to mg, and height is how much? Height is this much from the bottom, so it will be am. So we have to write down here a and m, and the kinetic energy ekb is equals to half m v b square. So at vc it is 0, so we can write down 2g m n. So we could write down here half m, and vv square means 2g m and n. So these two cancel out, so we could write down mg mn. So the total energy at B point, we could write down EPB plus EKB. So EPB is mg am plus mg mn. So this is EKB and this is EPB. So we could common mg part, then we could write am plus mn, and here we can see am plus mn, all together we could write down an. So the total energy we can write down mg an, right? At a point, the ground point actually, at a point there is no height. Indeed there is no height, so h is equals to 0. So at this point EPA is equals to 0, and EKA, the kinetic energy at a point, will be half m va square. So when it is traveling from B to A, so here at a point the velocity is va, and at initial point for this case coming from B, which is actually VB, and we have already evaluated the value of VB square actually, which is VB square is equals to 2gmn. So instead of VB we could write down 2gmn, right? So VA square equals to VB square plus 2g, and there is no height traveled, is it? Of course there is some height traveled. How much height traveled from B to A, which is actually am. Let's write down here am. So the value of VB, which is actually 2gmn, so we have to write down here instead of VB square 2gmn plus here 2g am. So 2g part is common, so here mn plus am. So mn plus am. So up to this much mn or nm to am, all together we can write down an. So instead of mn, we could write down an. What left? 2g. So va square is equals to 2g an. Now it's time to write down here half m, and a square means, va square means 2g a n. So these two cancel out. So we could write down mg an. So at every point, if we look back, actually we can find out the total energy is mgn. By the way, for a point, what can we write? That is ea is equals to pa, potential energy at a point, and kinetic energy at a point. So this is 0 and this is mg an. So ea equals to mg an. So at every point we found that ea is equals to eb is equals to ec is equals to mg an. So the law of conservation is maintained at every single point because the mechanical energy for every point is equal. So at C point, mg an, at B point, same mg an, and A point as well, mg an. So the law of conservation is maintained for this simple pendulum.